No, that quiz took me a long time. I thought I understood the stuff, but I guess I didn't very well. And I
Well,
didn't get through much material last night. I just had a lot to do.
no, I understand. Honestly, I only got halfway through the quiz because my wife has been kind of sick from pregnancy, and
Oh, that's never good.
as it turns out, sickness.
That's bad for finals.
Yeah, thankfully, Brother Sally's pretty understanding. He'll let me turn in the quiz a day late or something.
Oh, that's nice.
Yeah, he's been super understanding, which I am grateful for.
Yeah. I have a question for the potential. Did you get there wasn't one?
For number one,
Yeah, on the quiz.
no, I did get a potential.
Well, I did the test and it didn't match up, so I must have done something wrong.
Um,
Because you integrate them. I
yeah.
think I think I integrated it incorrectly, and so
Well, I ended up with yx plus zx plus xy plus c. I think.
that's what I was. Excuse me. That's what I was expecting, but when you integrate one of them with z, it seems like there's an extra term to me. I don't remember it
Oh
now.
my
I'd have to look
God,
at it.
you're right.
I don't know if it's right though. That was the only one I was kind of sure on. The other ones I just was shooting off the hip. Like I said, I don't really understand the.
Oh my gosh, I'm gonna have to go back and look at that today. Shh. No,
Yeah.
I'll probably leave it alone because that's not fair.
I don't know though, but
No,
I mean,
I just pulled up. I still have the quiz open from working on it last night, and just realized you are completely right. It is y plus z, x plus z, and y plus z. I thought that it was
oh
y plus z, x plus z, and x plus y. It is
yeah,
not.
right. That's what I thought at first too. So
Uh,
well, anyway, sorry. I thought you'd already. I shouldn't have asked that.
well, I already worked on the question, and I'll leave it alone because that's fair, and I can just fix it in the corrections anyway. All
Yeah,
right.
that's right. Yeah, that one I might want to meet with you to try to do that
That's
quiz corrections on that one because I'm pretty sure I'm not doing very well on that one.
Yeah, that's totally fine. I'm down for any work we need to do because
Yeah. Any extra points will help both of us for sure.
yeah.
Um,
I did take a peek at the test, and I am not excited.
no, it's a beast. It's how many problems are there? 15?
Yeah, and they look difficult. I understand why it's a take home.
Yeah.
Oh my gosh, if I had sat down in the testing center and saw this, I think I would have had a breakdown.
I couldn't have done any of it. I would have thrown down a few formulas and then handed it in. Probably. So I tried calculating the first one. Just where I started that one. Uh, I don't know if you've done that yet or not.
I've looked at it. I haven't actually tried to do it because I was working on the quiz last night when I
Right.
got
Well, I
home.
mean, I just barely started, so I haven't. I mean, I just glanced at it too. I didn't have a lot of time, but my plan was to work through as much as I could and then meet with you. But it just, you know how time is. It's the same for both of us, I guess, a little bit. But well, yours is probably a little less. So anyway, for 1A, I did do the little matrix test, and they do turn out to be equal. The nx equals my and px equals mz, py equals nz. So it does have a potential. So I'll let you catch up to me because that's basically where I'm at right now. I'm just working on B, and I can't remember what I'm doing.
Let's see.
I don't know how to do the bounds. I know how to find everything else, I think. But I'm not sure.
Well, the bounds have to do with the positioning between the points, if I remember correctly.
So we put the points in as the bounds.
Yeah, so between 5 and 1, and pi over 2 and 0, and 3 over 1.
Oh, okay, that's so much easier. Okay, because
And
I
we
did the
put-
parameter for the RT. I thought that's what that was for there.
I think that's what I remember. This test is open book, right?
Yeah, I think he said we can use everything but online.
Yeah.
Everything outside of what we have available to our course, I believe.
Let's see.
Well, seriously, if you want to go, you have to hurry.
Well, I think we can look at the homework, and that's going to have the examples we want, and it'll walk through how to do it. So,
Well, the thing I've noticed about the test is the examples he gives. When you turn off the TV, that might get our attention better. Most up there.
Come on, let's go. Let's go do Princess Girls. I know, but do you want to go to story time?
Okay.
That's what I thought.
You get
All right. Wait. I never realized this. I didn't realize that Math 215 and 214 can't both be taken for credit. That's interesting.
what's
Anyway,
what's Math 214?
I think it's Calculus 2. No, it can't be.
I know I'm a transfer student, so I don't really know all the numbers. This
Yeah,
is
I'm a
more-
transfer student too.
Oh, okay. So same thing, huh? I don't know.
Anyway, that was what I was looking for.
Yeah.
Um,
Man, I'm just okay. So it doesn't matter the order I do the bounds as long as I do them.
Come on, up the house. Come on, stop. Oh.
Okay, so RT over the length of RT.
Grab me a towel now. Yes, grab me a towel.
Let's see. Yeah, I've got to say it. The last 3 weeks have been the hardest of the semester for me. I understood everything up until this point, basically. Hmm.
Sorry, I just got a phone call.
Yeah, no worries.
All right, let's see. Do you know where can I find the formula for A?
For A,
Yeah.
give me 1 second. I'll just see if I can find it. If I can, I will share my screen. Okay, so I do want to say one thing. We've got this quiz or this test due Saturday, right?
Yeah.
And then we've got our final on Tuesday.
Yep.
That's like no time to study with trying to do all this.
And I haven't seen a review for it either.
Yeah, but I don't have a towel for you. Sorry.
Yeah, and that too. So
1 second. Let me help my daughter.
yeah, no problem. You take as many breaks as you need or whatever. Okay, let's see. That was week 12, I think. Oh, you're kidding me. Uh,
Ah. You're so much better at finding the formulas than I am.
I just looked on my. When I do my notes, I pretty much follow the way that he has it output, or the way he
Yeah, I talked to him at the beginning. I actually can't take notes. I
yeah.
can barely do the tests and the quizzes. I have
Mhm.
carpal tunnel, and so handwriting is hard.
Does he? What about typing on a computer? Is that hard too?
Typing's not too bad. I mean, I'm a computer programmer. As long as I have the right keyboard, it's pretty good.
Gotcha.
But the problem is, have you ever tried to do math notes on the computer?
Yeah, it doesn't work.
Not very well, no.
No.
Um, So basically, he told me at the end of the semester if, like, I'm off by 1% for a grade, he'll just bump it up by 1%.
That's cool.
Yeah. But it has made quizzes difficult and finding things difficult.
Mm-hmm. Yeah. So anyway, here's the formula for it. There's
Yeah. Let's see.
so you got a tutor there with you, huh?
Yep. And he's very excited to help me.
Sounds like it.
Yes, he is. All right. This partial derivative is not agreed, then it can't be a gradient field. There should be some. I don't know if there's a lot, but there should be some. All right. I'm going to quickly pull up those notes on my screen so you can get back to...
Oh, I've got the review right in front of me in my notes, so I'll be good for a while.
Oh, okay.
If I need anything, I'll let you know, but I'm gonna see what I can, if I can at least formulate some of them, and
So wait, are we testing for the gradient field?
well, yeah, well, that's what I always do first. So that's saying if it equals it, then you know you have one, and then if you wanted to solve it, where is that? I watched the video on it, which was a lot more helpful than reading this stuff.
Okay, finding a potential.
So here's method one. Method one was confusing. I think method two is the one we want. I think that's one you were explained to me when we were doing our group quiz. So you take the integral of each of them, and you find the like terms, and if there's a like term match in each from each of them in total.
Okay,
And
so that's what I thought. I found out why I was wrong on question 1.
Why is that?
It was because I combined them, and we aren't supposed to combine them.
Oh, yeah, treat them separately, maybe? Yeah,
Well,
I can't remember it.
It basically,
Like I said, I stopped because they didn't match.
Oh, I meant question 1 for the group quiz last week.
Last week? Oh.
Yeah, the reason why we got that one wrong is because I combined all of them.
Yeah, I didn't know much about potentials then, so I wasn't sure. Still not sure, really, to be honest.
Yeah, the key there. Not repeating duplicates. Okay.
But they have to have a duplicate, right, for it to work correctly? Or is that only...
It never says that.
I thought that's what it said in the video.
Oh, well, it might say that in the video.
Because I watched it and they did this A of Y, Z constant thing. It was weird. I don't know. I didn't like it. It didn't make any sense. And so I tried this way and it looked like they had to match up, but maybe they don't. Because it made it sound like right here that you just sum the terms and you don't repeat the duplicates, so it doesn't sound like you have to. But in this one, they have them.
You want to know what it just... Oh, there's the... Okay.
Kind of weird. Okay, so those cancel.
Seriously, be aware where you're going. Pay attention.
Does it not get a plus C?
I put on a plus C there.
Okay. I thought that I got a plus C. Okay,
Just because we don't have any bounds and we're integrating.
So what did we get for A?
For A, excuse me, I have x squared sine y plus zx plus c.
Whoa, what? Okay, so can we walk through this? Because I got a very different answer.
Let me take a picture of my work. I think that's going to be a little easier. Then that way we're both looking at the same thing.
Okay.
I think that seems to be easier than for me to explain it anyway, because I'm thinking I'm saying one thing.
Oh, it gets rid of XZ. Okay, so it is only like terms. So if it's only like terms, then it would actually only be that, which is still a different answer.
All right, give me 1 second.
I don't want to hurry this at all.
Yeah, I want to get as many points as possible. So
The higher grade I get on this, the worse I can do in the final and still pass the class.
yeah, as long as I think if the final covers everything else, will be okay. But if it covers this stuff a lot, I'm not gonna do very well the last 3 weeks. Okay, let me get. Excuse me.
Let's go, Noah.
Have fun, you guys.
Oh, we got out.
I know you're upset that you don't get to go, Malachi.
Malachi, when you get old enough to sit patiently while someone reads, we will take you. Okay? You don't quite have the patience yet, buddy. Yeah, mommy's gonna
Sorry, my son's gonna be upset for a little while.
No problem. Oh, you can't read my handwriting.
Yeah, I can.
Well, part of it, at least the
Well,
beginning part on the top right is really faint.
wait a second. I should be taking the integral, not the derivative, right?
Yeah, the integral, exactly.
Oh, that's what I did wrong.
Yeah, because we want to find just the regular f, and that f is treated like the what do you call it? The gradient of f.
Yeah.
Yeah.
I see what I did wrong.
Yeah.
Wait, but it's a partial derivative.
Yeah, but for this one, you just have to integrate. Here, let me go back to.
Malachi, buddy.
So here's your mx or your m, right? And it just says you need to integrate that one.
Okay, I love you, the pieces.
Okay, yeah.
So this one's with respect to x. This term's with respect to y.
Okay. Then you'd be correct because I went the wrong way.
Well, I did too, so it's okay. I think we're in the same boat here.
Because that would make that x squared sine y.
Love you, Malachi. Come on, Noah. Yep, it is raining.
I know, buddy. Sorry, I'm just doing it myself.
No problem. I'm just having that so you can kind of glance and see if. And mainly for the next part because I want to make sure it's working out right. The only thing I'm not sure about is the bounds because I changed everything, parameterized everything. So I don't know what I'm doing there.
Is it going from cosine to sine that's negative in integrals, or sine to cosine?
So it's sine to cosine. So
The opposite is.
When you take the derivative of cosine, it's a negative sign. So it's just opposite with the integration. So it's confusing. Yeah, I got it wrong at first. I was like, oh, they don't match up, but they do.
Malachi, buddy, breathe. No? Okay. Malachi. I know it's sad. So wait, what did you get again?
I got x squared y zx plus c.
Where did you get x squared y from?
Okay, so when you integrate this first term,
Yeah.
you got the x there, so now that becomes x squared over 2. Like it's sort of the 2, so that's 2. Or sorry, that's just going to be x sine y, and then that's going to be your zx, of course. Then when you integrate this with respect to y, it becomes x squared sine y. So those two terms are the same.
Oh, you can do that?
What's that?
I wasn't sure if you could do that because it has the plus zx.
Yeah, let me show you. Okay, let's see. Where's this example?
What could I do to make it better? We're so happy. Okay.
Well, okay, so in this example right here, you have this x squared y2 term.
Plus xyz. Okay.
See how they're like terms there? So you put that there, just one of them. This is like that one, so you can put that there.
The problem with the example is that it still uses all of them. But
That's what I did. I used all of them too.
I guess I see what you're saying.
Give me one sec. I think this video. Let me see if I can find where he's talking about it. Here, I'm gonna. Well, I'll just play it real quick. I'll just turn off the sound. Oops. Maybe I need to listen to him actually. Here, I'm just gonna go back a second. I'm gonna turn up the volume all the way, and then maybe this will help us and make sure it's right too. Let me turn up my volume though, so you can actually hear.
All right. I actually can't hear, but that's okay.
At all? Wow. I think I maxed out. Okay, now I'm maxed out.
I kind of wonder if it's intentional, but let's see. Yeah.
So you can't hear it at all, huh?
I think that that might be an intentional thing so that you could watch a video while still on Google Hangouts. Or
well, I can put closed captioning on maybe.
Yeah.
He does it two different ways. I think this might be the first way.
Wait, he's just putting all the terms whether or not they're the same.
Yeah, he's saying I'll just let him finish this real quick.
Yeah.
Okay, so from what he said earlier, he said that these terms must match. And where we've got three of them, the three of them have to match for it to be a potential. Because if you do your n, what are the terms again? Your nx must equal your mdy because of the matrix diagonals.
Yeah.
So those are going to be the terms that you're going to be seeing anyway when you integrate. I think, right? No, that's not true. That's opposite what I just said because you're doing the opposite. But anyway, he just says they've got to match. So that was just here. Okay. He says if we want to find the potential, it is just to write down. Oh, that's the wrong spot. Oh, shoot. Did you hear what he said right there?
I did not.
Or see it? Gosh, I know you can't hear it. I'm being dumb. Let me get right. Okay, so he said that should be the potential on the left. So he said these should be the same.
Okay, they are not. Unless I am misunderstanding something.
Well, so we have three of them. They have to have the same terms, basically. You can't have extra terms.
Okay.
As far as I understand. I don't know. So in this one, he just had an example of x and y as a constant when you integrate.
Yeah.
And even though those aren't defined in the one side, they are over here. Like this one, I think 6y squared. No, that would be 3y squared. He didn't reduce. And since that is a term that only relates to y, it goes to right here. Constant that relates to y. That's all he's saying right there. That depends on y.
Okay.
But this term matches.
Yeah.
And like I said, that one would, because with respect to y, there's a constant with respect to x.
Yeah. But he keeps all the terms.
Yeah, he says these should be the same on both sides, and you only write down, like it says, or you don't repeat.
Yeah.
But I don't really understand it. I don't know if you can have some that have extra terms that aren't correct. I don't know. But anyway, that's why I got the x squared side y, excuse me, and the zx, or xz, however you want to do it. And that's more closely following this right here, how they did this. They matched terms and wrote them down.
Yeah, but the problem is they don't have any terms that don't match.
Yeah, I know exactly. But in this one, we only have terms that match.
Wait, what?
We only have terms that match. I mean, the integrals aren't exactly the same, but we have the same amount of terms that have been integrated. Does that make sense?
Sure, but only one of our terms match in our problem. Actually, that's not true. Two of them do. Three of them.
Yeah.
Two of them.
We only have two different terms. Excuse me.
Wait, what?
We only have two different terms there, but it would
Well,
be the same as if I were to take out this XYZ in this one and the XYZ in that one. Oh, I know. It would be the 3YZ in here and 3YZ in that one.
but wait, don't we integrate each part of it for X, Y, and Z?
No, you just do M. So you do this whole thing right here with respect to X. Because if you think about it, this is the what do you call it? The gradient, right? Which this term would have been the derivative of the original function with respect to X. And that's what's left over.
Okay.
So that's why you only integrate with respect to X, because you're just undoing what you did before. And then same with the Y, same with the Z.
Okay, and that's why we only end up with x squared sine y plus zx plus z.
Yeah, as far as I understand.
Okay. Okay. That was a part that I was missing.
Yeah.
I thought that you did all three and then compared them.
No, you do the different derivatives from the vector field to see if it has a potential. But other than that, you just integrate by the position it's in.
Okay.
And then I don't know if this method works. Let me see 1 second.
Given that information, I agree with your answer completely.
Yeah.
I'm sorry. I'm not trying to be.
No, we're trying to make sure that we have it correct. That's what's important. Just because I think I might have it right doesn't mean anything. And this is the only time that I think I might have it right, is this one. So method one does a weird, I don't know. It's probably not worth even talking about now, but I don't know if this, I think it gives the same answer. Oh no, it's a different problem. I thought it was the same problem to show it's the same.
No, it's not.
So that doesn't help. Never mind then. But anyway, that's something we could talk about another time when we do our test or quiz review.
Yeah.
All right, so now we are on part B, right?
Yep.
Do I need to pull up the quiz on here or the test on here?
No, I have the test up.
Okay, good. Yeah, like I said, I have mine printed, so I didn't have to look at my computer screen.
Yeah. I hope to be able to print it. I need to fix my printer.
Oh, that's not good around this time. Final, basically just
Oh no.
pre.
My printer went out like 3 weeks ago, and I just haven't had time to try it. Well, I've tried to fix it, but it's a problem that apparently is going to take a little bit more focus.
Yeah. Well, and it's hard to do that with excuse me, with finals week and all that.
Yeah, and working full time, but I probably should anyway. Let's see.
Yeah, after finals you can do whatever you want, but if you need to do it before then, I don't know. So this is my part B. I don't know if that's the correct way to do it or not.
So you're just integrating. By the look.
Yeah. Yeah, I'm just integrating.
The only thing that's throwing me off is the F dot TDS. I don't.
Oh, I did it wrong.
That's the only thing that's making me hesitant to do it that way.
Okay, so the F, which I forgot to do, is this right here.
Yeah.
Wait, no, this right here.
Yeah.
So I forgot what we need to do.
Do we need to take the dot product of it?
Yeah, we put the F down here and take the dot product of this what I found, which is your R of T.
Yeah.
And wait, that can't be right. Sorry, I did that wrong completely. I see now. We need to change the parameters of X, Y, and Z through the R of T. Plug that into F. So it's F R of T, and it's going to equal. I'll have to redo it and show you what I mean. But basically, you just change it so this is all T's. And then this is supposed to be R prime. So this right here is actually R, but this needs to be R prime. And I didn't even find R prime. What the heck did I do? I see. Okay. So I'm gonna redo it and then I'll show you what I'm thinking. Just know that's sort of that's the right approach to get R of T, but everything else after that's wrong.
Okay.
Gosh, this one should be the easy one too.
What lesson is this?
Okay, this one. Let me look at my notes. Well, he's combined a few of them, so.
Yeah, I know. Like I said, his tests are usually more difficult than, much more difficult than the homework assignments.
Yeah, he usually has pretty good reviews though, and that helps me a lot.
The reviews he has are super helpful.
Yeah, I have another class that the review is not even close to the exam, so it's like a shoot off the hip if it even helps you.
Well, I mean, he always has a couple of problems that weren't on the review that throw me off.
Mm-hmm.
And I swear I never get those right. But
yeah, no, I'm the same way.
I'm trying to remember how far back this. Oh, I guess we go all the way back to week 10.
Yeah, I was looking at my notes. Week 11 I have an example of it.
This isn't transformations. Yeah. For one, that's double integral, and we need triple.
We just need a single integral because we're going to be plugging this right here, 2t plus 1, in for every x we have up here. So it'd be
the t thing.
Yeah. Yeah, so like I
that.
said, I did that wrong because I was trying to think, how in the heck do I do that? Because that's why I was messing around here with these bounds. I'm like, those don't make sense. I can't do a triple integral with just doing a dt. Yeah, let me find where that is, and then I will. So that's week 11, I said, right?
Yeah, I think it's work, flow, flux, gradients, vector fields. So less than 37.
Oh, so you think you found it then?
Well, I think that's what it is because this is gradients and vectors, but
yeah, you're probably right. I think that's where I would be looking at too.
Oh, F dot TDS. Okay, for the vector field. That's the thing he does. So all the examples in the homework are for 2 for X and Y, and then he throws Z in.
Yeah.
And it should theoretically be the same, but I always
Yeah, it's confusing. You just need to remember that whatever the Z position is in your F and the Z position in your RT, you replace the Z and F with the Z and RT, I guess, if that makes sense. Here, let me try to bust through it real quickly, and I'll just start in another piece of paper so I've got it right. That way I can show you kind of where I went.
So do you just turn all the X's and Y's into?
Yeah, every single X and every single Y. Yep. It's not just the X position, and the M, but then there's an X in the Z and in the Y, so those get changed too.
So big F is the yeah. Okay.
Is this your hardest class this semester?
Oh, by far.
Yeah. It's pretty intensive, that's for sure. Okay, so RT. So it's going to be the head minus the tail, right? At least that's what it said in the video. I'll try to write it so you can read what I'm doing. A little better than the last one, anyway. Some reason that ink didn't show up very well. I'm part of it.
Oh boy. I found an exact example. I'm a little confused by some of it.
The only thing I think I understand the steps for the rest of this, except for the bounds, because now I'm changing it to R of T. I don't know how to do that exactly.
Well, I will find the bounds.
And then I'll show my work here in just a second. Well, it's going to take me longer than a second, but I'm going to just set it up and then they can... Actually, it might be just quicker if I just do as much as I can.
Oh, where did you get the 2-in-1 from?
Okay, so let me look at... are you talking to me or on that example?
On the example, I'm confused.
Here, go ahead and share your screen. That way I can see what you're looking at.
Sure. Let's see here. Oh. That's weird.
Well, I'm not seeing your screen yet. 1 second.
Sorry, I was trying to share my screen and it seemed to get upset at me. All right. So can you see everything?
I think so. Oh, now I can't.
You can't?
Oh, it's when I'm talking. It takes it away. I see now.
If you click on my screen on the bottom right, it'll force that screen to stay up.
Ah, I see. So I had it on me, and so whenever I talked, I see. Okay, now it's better. So the vector field.
It is a much simpler problem than we're dealing with.
Along the curve x equals y squared.
Except for we don't know what our curve is, do we? We're just given the points of our curve.
Yeah, we're just given points. But I don't understand why T's the way it is on there.
Well, I understand T. I don't understand why there's a negative here. It might have to do with this.
Yeah, so to find the R of T, it needs to be 4 minus 1, comma, minus 2 minus 1, all that times T plus the 0.1 comma negative 1. But that doesn't make sense to me because it doesn't have any of that. And that's how I was solving this one. RT, they just put T in for X and Y.
Except for they made this negative.
Yeah, and I don't know why that is. If they're going to do that, that should be the square root of T.
Wait, why should it be the square root of T?
Because X equals Y squared. And if you have T for X,
Well, I think
then,
the T squared is actually coming from the X squared over here.
well, I know it is, but I don't know why, is what I'm saying. I don't. All this stuff was done so we learned so fast, so much of it. I don't really understand it. Ever since we started doing the triple integrals, it just seems like it's been pretty fast paced and.
Triple integrals by themselves are not that difficult. It's the application of the triple integrals that I'm
Exactly. Yep.
struggling with.
Yep. That's the hard part. Well, let me finish my thing, and we'll see how closely it relates to that because that's a little confusing to me.
Sounds good. And that is the only. That's the only one that we've done of that.
Yeah.
That's the thing that frustrates me is that we don't have enough math problems for the stuff that he cares about and wants us to test on, you know?
Exactly.
So we end up with almost no examples.
Or examples that don't quite relate. They're close, but just enough to lead you astray.
Yeah.
At least that's how I felt with every test. And the quizzes especially.
Well, quizzes honestly weren't that bad for me for most of them. So
Just this last one really was a hard one for me.
I did great at the beginning, but the last 3 or so I haven't done well on.
Yeah, they're just it's the end of the semester and everything's just kind of crazy, I think. So I am thinking we probably are gonna have to meet again.
Oh, definitely.
And we'll see about juggling time and whatever later, but
Well, I'm good all day tomorrow after my interview.
yeah, I do have it's just hard because I got to juggle my other classes, so I got to think. I could meet in the morning. That should be fine, or whenever you're done. I do have a thing later at night that I have a group meeting for, like 6ish.
Yeah.
So I need to start getting ready for that.
Well, I hope between today and tomorrow we could still get it done. I mean, he expected us to be able to do this within 2 hours.
I can't do his regular test in 2 hours, and this is longer.
I have no
Well,
idea.
what I'm thinking is we'll do what we can today. I'll stay up a little later, and maybe get up a little earlier tomorrow too, and then I'll just try to work through as many as I can, and then I'll upload my work for you, or take a picture of it so you can kind of see what I did, and we can say, hey, that's not the right attempt, or whatever.
I'll do the best I can, but
Like I said, most of it I'm probably not going to understand. Like, number 9 just seems really hard to do.
yeah, the further I go in the test, the more I'm just like, this looks so complicated.
Stokes' theorem, I only got a few problems done, and then it was past midnight, and it's like, it's not worth it to get partial points. Plus, I
Yeah.
had a quiz due in another class. That was just frustrating. I just seem to never have time for the homework. That's what it feels like, because it takes too long to do one problem.
Yeah. Towards the end, it definitely felt that way for me.
Yeah.
I was great at getting it at the beginning, but
I think everyone feels the same way. It wouldn't be bad if it actually really helped us do the material and understand it, but like when we were doing, you had to find the mass, then you had to find the moment about X and Y and all that, and then you had to do the inertia, and then in each direction. And that was like 54 parts that you had to derive for one problem worth only 1 point.
yeah.
That's not worth our time for 1 point. It's worth to understand it, but not like that. I think a homework problem where you have just doing like the mass, make that quick and easy. Do easy problems instead of making them complicated and long.
I'm also sad that we're not doing any of the work and flow on this test.
Yeah.
That was something I actually understood.
There's not even one on that, huh?
Nope.
I thought I understood it till I took that quiz, and I'm not so sure.
I am confident in those 2 questions on the quiz.
I followed the formula from when I copied, but I have no idea. Okay, let's see. I'm going about this a little slowly. Okay.
I'm still just trying to find it in his reading.
Yeah, it might be even assumed earlier than this for doing this part.
Yeah, I assumed it was workflow and gradients and vector fields, but he doesn't have it in the reading there.
No. Yeah, the reading's not super accurate sometimes. As far as what you need to, look up, it's almost easier to look up homework examples.
Well, yeah, but I only found one example, and that's where I found it.
Yeah.
And as we discussed, not sure how helpful it is.
Yep, exactly.
You need more milk? Okay.
So how much time is this easy one taking us? Because the other ones are a lot harder.
Almost an hour.
An hour a problem. Okay.
So 15 hours on this test.
That's not comforting at all.
No, it really isn't.
I know he expects us to understand it enough to do this in 1 second, but there's no way.
Not on this one, at least.
I think some of the teachers forget how hard it is for students to, because they've studied it so long, they know the material, and they've had to work it a lot. Oops, I forgot to do that. Sorry, I'm going about it real slowly, but I want to make sure that you can kind of follow my steps and see the important things think that need to be applied, and then we can go from there. Oh, from that one example, did it show you how they got the bounds once they parameterized it?
I have no idea where they got their bounds from. They said A and B, and it ended up being 1 and 2. And I had no idea where they got 1 and 2 from.
Huh. Yeah, I don't know either.
However, I did find an example in the reading, finally.
All right, that might be good.
Maybe. I still don't know where they got their bounds from, though. Their bounds is from pi to 0.
From pi to 0.
Yep. And from 0 to -1, apparently.
Okay. Well, if we can at least set it up all the way, even if we don't have the bounds right, whatever. We can do that. We can figure it out, I think, once we have everything else working, maybe.
So big F with the arrow, is that what the original thing is, technically?
The big F, what do you mean with the arrow?
Like, we have F equals and then that vector field.
Yeah, that's that F, exactly.
The arrow above is vector, right?
Mm-hmm.
Okay.
Yep, exactly. Yep.
Just wanted to make sure before I went further.
Yeah, no problem.
Then we found the potential.
Oh, this is a nightmare. Holy cow. There's so much algebra. And I probably take longer on these quizzes and stuff because I tried to do it kind of how how I've been doing it on there, just try to make it nice and neat. Although the last one didn't look very neat, but that's usually my rough draft isn't very good and just takes forever. It feels like.
Okay.
I'm almost where I can. Oh dang!
Wait. The flow.
Well, we're not doing anything with flow. We're just doing the line integral where that curve is.
Oh, because we're doing TDS, not DR.
Well, ds equals what is it? dr, which is the magnitude of r of t prime times
So
dt.
wait. Look at this. Oh, that's not it. Is this what we're looking for?
R. So are we overcomplicating it?
Well, if we're looking for that, then we can use the fundamental theorem of line integrals and it becomes really simple. Or we can do it the long way, but
Well, apparently I'm doing the long way. It should give us the same answer, so try doing it the short way. Well, our R of t is parameterized, so it has to be.
still don't know where they're getting pi from.
Okay, let's see. Let's look and read the problem. So it says it's the upper semicircular curve in the plane starting at 1, 0 and ending at -1, 0. So the semicircular curve is from 0 to pi, followed by a straight line segment from -1, 0 to 0, 0. So what's that mean? Oh, just
I don't know, but it's using the 0, 0 and the 1, 0. And we don't have those. So how does that affect things?
None of that makes any sense.
Nope. Not to me.
Okay, look at where the integral is. The first one under the R1 and R2. I don't know about the bounds, but see how this was what F is right there, the cosine T, but you plug in the R1 into it.
Yeah.
However they figured out the R1. I don't know that one. Oh, because it's the semicircular curve. How would I know that's a cosine T and sine T together?
I have no idea.
I don't know. Never mind. That just is.
Oh wait,
making me-
cosine t plus sine t. That's just the original is x plus y, so it's just changing it from x to t.
Oh, okay. That makes more sense now. I was looking at a different spot because there's a lot of numbers in between there.
Yes,
Not
there.
really, but there's not really a lot, but in my mind it seemed to be.
And then
Okay, so then the negative sine T
that's the
derivative.
derivative of this. And I don't know where these rounds are coming from.
No, see, I thought that one was the one with pi.
Nope,
Oh,
this
plus.
is
Okay.
one.
So if we look at the word problem, so we have the semicircular curve,
Yeah.
which is going to be from radians and
Oh, unless we're told otherwise, we should assume that it's between 0 and pi because it's a semi.
yeah, it's just the upper half,
Yeah.
above the x-axis, so it's going to be from 0 to pi.
Yeah.
And
That
then the other one being, what's the bounds on it? 0,
0,
negative.
-1. That
Well,
probably has something to do with the line segment.
I don't get that part because when you, I don't know. How in the heck did they get R2 though? If I can figure that out.
I have no clue.
They don't even use the potential in there except for, I guess, that next part. So that doesn't help me much.
Where's R2 coming from?
Gosh, I don't know. I thought it was. Oh, wait. No? Okay, well, maybe I did this one wrong then. Okay, so earlier when we were doing parametrizing,
Yeah.
remember if you have 2 points, you take 1 point, subtract from another one, multiply that by t, and then you add the one I think you subtract from, possibly, or the first one. Yeah, you add your first one. So maybe I did my things incorrectly then.
Here's the fundamental theorem of line integrals, and proving that that works.
Yeah. The problem is I still don't know how to do the bounds. Unless we do a triple integral, but that's not what they want us to do. Here, I'm gonna look something up real quick. Make sure I have my parameterizing correctly. I can't say that word for some reason.
Yeah.
Unless I say it real slowly. Oh, whoops. I almost Googled something. Good thing I didn't try to do any more than that. Let me look at my previous notes and see where I need to look. And he said we couldn't refer to our other quizzes or anything, could we?
Take notes.
Yeah.
But Lab does not give you a complete picture of what you need to know. Really? Practice the way you will test. Can't use certain calculators or technology on the final, but use it on the homework. However, it doesn't say that we can't use it on test 4.
Oh, so that's just for the final with all that?
Maybe. The exam will open Tuesday night. You will want to complete the last 2 lessons by then. He suggests 2 group meetings. One, meet for an hour to discuss it, and then set up a second meeting for Saturday to go over things.
Does he know it's conference weekend?
I don't know.
That's one thing I was telling my parents is that I just can't believe for a church school that they make you do all this stuff during conference. I have 2 math classes and they both have like the same due dates for everything, so it just makes it really hard. Everything's due on Saturday. I'm getting closer. I thought it was in the beginning we did.
I don't see anywhere that he says that you can't use any resource available.
On this test?
Yeah. Maybe you said it in an email.
Because I don't know where my notes are. I thought it was earlier in the semester where we got points and created a thingamabobber that I can't explain. The R of T.
Yeah, it just says to take home open book.
Open book is all.
Well, that's what he said.
Well, my book hasn't been their book. It's just been online because I don't understand anything in the book.
That's true. So I think it might be fine if we're trying to get a better explanation as to how to do a type of problem, as long as we aren't necessarily looking up the exact problem.
Gotcha.
Who knows?
Oh, I'm just trying to remember how to create your R of T, and apparently I didn't write it down. Or that might be the one. I was missing one, so that might be the one I'm missing. Anyway, I thought it was your Oh, I think I did it. I think I did it right. I think I'm just second guessing this. No, I think I am wrong. Here, I guess I'll just look it up just real quickly.
Wait a second. Oh my gosh. Hey, have you looked up at the equations above?
A little bit. Why?
Look at circulation, which is on the same line as work/flow.
Uh-huh.
Do you see it?
Yeah. So that means we just need to find the F.
Fn minus F start.
Right, and then we plug in the points. So I don't need to parameterize it like I'm doing.
All we need to do is plug that into the answer we got for part A. That's why he assumes this test will go so quickly.
Okay, yeah,
We
I
could
think I was gonna get almost to that point. Okay, so let's just do that. That's
Oh my
scratch what I was doing. It started to look nice.
I'm sorry.
No, it's fine. Don't, like I said, the only thing I wasn't sure about were the points. Everything else is pretty simple. But so we found F, and F is our x squared. Wait.
Oh, and that's why it's pi over 2. Because there's only
I have to remember what I did because they changed it. So it's x squared sine y,
wow.
and that's plus z. Oh, yeah, plus zx. Are we adding the c in there still?
No. So it literally breaks down to 3 squared. 3 squared sine pi half plus 15 minus sine of 0 plus 1.
Huh. How about that?
Oh my gosh. Ugh.
Well, I'm glad you caught that because I wouldn't have even known.
I didn't even mean to look at those. I don't know why I did, but I'm happy that I did.
I'm happy too. Okay, and that's minus. Oops.
Okay.
I'm almost there. So it's going to be 9 plus 15 minus 1, right?
9 plus 15? No, it'd be 9 sine pi over 2 plus 15.
Pi over 2 is 1 in
Okay.
sine.
Then yes. I don't know. I just put sine pi over 2 in my calculator.
Yeah, because remember, that's 90 degrees.
That
And
makes sense.
sine of 90 degrees is 1.
Yeah. But I was never very good at trig.
I don't know. I don't really remember much. I remember that and cosine, but when you start doing like 45 degrees or pi over 6, it's like, what? How am I supposed to remember all this square root and not square root stuff?
I was
So,
great at algebra.
yeah,
Yep.
I'm the worst with algebra.
Not so good at geometry and trig.
I think the main part is the algebra in it, at least for me. But
Well,
there
that
are
came
so
out a
many
lot.
theorems with geometry, it's ridiculous. How can anyone be good at it unless you spend your whole life doing it?
Yeah. Well,
So it's 23 for the answer. Or,
Yep.
yeah, okay. All right, I'm feeling pretty confident about one.
yeah, I'm just sad it took us that long.
Well, I'm glad that we got it right. That's all I care about.
That's true. Just the answer was right there.
So maybe we need to look up there before we do anything to make our next plan of action.
I agree. The only problem I had is when I was looking up there before, it looked like gibberish to me. So
Yeah.
my brain just kind of put it to the side, you know?
Mm-hmm.
So we're calculating the flux of the vector field.
Flux, where are you hiding?
Flux is at the top.
Yeah, I see now. So all we need to do is take the m with respect to y, a partial
Yeah.
derivative, minus n with respect to x. So isn't that going to be 0?
Yeah, because m with respect to y. Wait, does it become xy?
No, you're... Okay, this one's weird.
Or are we trying to find the derivative?
It has a circle with radius of 3.
At the origin. So that means that it goes from 3 to -3 on both sides.
Yeah. For both x and y.
Yep. So that means that a and b would probably be 3 and -3.
Mm-hmm. But he wants us to set it up, right? But what I'm seeing is it's going to be 0. Minus 0, isn't it?
No, because mdy would be xy, wouldn't it?
No, you're doing the... So you take the partial. Let's see.
Well,
Let's
that's
look
what
at...
we were doing for the previous one.
Well, it's... So if you think of it, it's going to be your partial is your dy minus dx in a vector, and that's dotted with your m and your n.
Yes.
So your m would, when you take derivative with respect to y, is going to be 0. And your 2y taken with respect to x is going to be 0. So isn't it just going to be
But
0?
in problem 1, wasn't mx x squared sine y?
That's finding the small f.
Isn't that what we're doing?
Um, let me see if I can find a good...
I don't see why that would be different.
Here, let me write something down real quick, so maybe it makes sense. So we've got our f, which is what again?
X and 2y.
X and 2y. Okay. Actually, maybe I can use Mathematica. Maybe that will kind of explain it. Or at least I can write it down. Maybe quicker than writing it on this. Okay.
And the homework, they're sitting there. Not the homework. The reading, they're sitting there and changing it to RT first.
RT. Seems weird. So
Yeah.
anyway, here's what I was thinking: is that's your m and your n. If you take your derivative, so with respect to, like it says in here, m dx, right?
Yeah. Well, actually, it's MDY.
Oh yeah, you're right, m dy, and that is going to equal x times dy, which is going to equal 0, isn't it?
I don't know.
That's how I've been doing it, so maybe
Yeah.
I've been doing it wrong the entire time.
No. I mean, XDY would be 0.
And then so that's 2y
It
times
just
dx.
doesn't make sense to me.
Oh, I know it doesn't make sense, but I don't know.
I don't know why he would have that question on here then.
So, like I said, I think that's what I was wondering. Isn't it going to be 0 minus 0? So let's do what you said and look at some more examples. I guess I'll keep sharing. I don't know. We don't care about writing shell program. Scripts, that's what I was studying last night. Taking a quiz on anyway. Right here.
Like I said, I understand. Oh, excuse me.
Let's see. What would be week 12, I think.
Week 11 actually.
Oh, is it?
Work/flow/flux/gradients.
One of the two of them?
Yeah. I'm gonna take a peek into homework. I doubt it'll help us, but
I don't know. You never know.
you don't need to find the gradient field.
Okay, let's look at this example. Here's an example where they do use the R of t with a negative y in x and an x in y.
That's what I was looking at.
Oh, was it?
Yeah.
Well, I think that might be right because
But they go into R first.
yeah, okay, well, our R is 3, so it is a constant. So we only really need to take an integral with respect to theta. Or in this case, t. So I think you're right. I think this is the exact one we need to do. Because the way I was going to do it would just make it 0. But where he gives us the radius, that's got to be it.
I just don't know what to do with that information.
However, this is just the circulation, right? So we need to. Well, what does that mean? C parameterize CCW. The heck? Sorry, I was just looking at this formula on the right.
Yeah.
I don't know what that means.
Or I don't know what CCW is.
Yeah, exactly. Same.
And obviously that's an important part of it, and I don't want to ignore it. I just I've never come across CCW before. So
Let me look at my notes, see if what I have. Yeah, I think I am sort of right. So it's, I don't know what the C parameterized CCW is, but you have your, wait a minute. That's doesn't make sense. Sorry, I'm confusing myself. It doesn't seem like I've written it down correctly, but maybe I have.
oh, would A be 3 in this case?
I think we're gonna do what we did in this example. I think A and B are gonna be 0 and 2 pi,
Yeah, but
and then our where our A is in the,
that'll just be 3, right?
yeah, exactly. So we're just gonna set it up just like that at this point right here. We'll put the terms together, and we should get something similar to that. Well, I hate that. So it's going to be our r squared, which is going to be 3 squared,
Mm-hmm.
probably dt. It's just what I'm assuming.
Yeah.
I think that's going to work. But I just want to make sure that we're doing it in the correct way.
What
'Cause
I'm a little confused about is how he's getting A cosine t and A sine t.
So it's r cosine t for parametrizing it, where
Why
a
is
just
it-
represents the radius, and up here defines radius as a.
Yeah. But where is cosine t coming from?
T is just the theta.
Yes.
So they're parametrizing it so it's in polar coordinates.
Yeah, but I thought that the polar coordinates came from the original problem, so from y, which y is cosine, right?
That is weird. Why is that the case?
Which would be fine, but shouldn't it be negative cosine t?
Okay, so here's your f of your
Yeah.
big F. It's right here. So that's exactly what you're saying.
Oh, okay.
But to parameterize it, they just have this, and then they take the derivative of that, which is the same thing.
Okay.
Yeah, it took me a sec to figure that out. However, we're not finding dr, we're trying to find our nds. So now I'm trying to find something similar.
Or Indians?
Yeah, because it's, let's see.
Oh, I see. What do you
Yeah.
need help with, bud? Maybe you could stop trying to get into places you shouldn't. You wouldn't have problems. Okay. I don't know why I keep looking at your screen. I have it up on mine and it's bigger. I keep going back to yours to look at it.
Well, I can stop sharing if that helps.
Well,
Because we're just looking at the same thing
yeah.
there. I think it's close, but I think we need to find one with flux and not with. It's really close.
Well, this is flux.
This flux, it's a circulation.
Oh, I'm looking at a slightly different one that does the exact same thing.
Oh, it's right below it.
Yes. Well, a bit below it, but yes.
Oh, a bit below.
But it comes to the same answer.
So it's what I thought. It is going to be 0. So I'm right.
Except for we're not trying to
solve.
We're not trying to solve it. We just need to set it up.
So the one I'm looking at, it has the line integral with with respect to c or whatever. M dy minus n dx equals the integral of 2 pi or 0 to 2 pi minus a squared sine t cosine t plus a squared sine t cosine t dt.
Okay.
Is that what you're saying?
That is. I just need to figure out how the freak they got there.
Okay, so if we put we could do it in a few different ways, really. So with our x and our y, we could just replace those with cosine, 3 cosine theta, and it would be essentially 6y or 6 sine theta, right? And then we just take them with derivative. Oh, that is confusing. Oh, that's not too bad. Let's just kind of follow how they did it. So let's find our r of t, which is just going to be our radius cosine t, radius sine t.
I just don't understand why it's not in respect to the vector field. Because then why do we even know what the vector field is if we're not using it?
We do use the vector field.
Where?
Okay, so this example skips over it, I think. Wait a minute. Sorry, let me relook at this. What? That doesn't make sense, actually.
That's what I was saying.
That's almost the same problem we have, just why is it so confusing? Well, you can do it the longer route, which would be your vector field parameterized. So that for us parameterized, that would be cosine t, or sorry, 3 cosine t, and then 6 sine t. Dot that with our n, which is going to be our y prime comma minus x prime. That's one way to do it. I think that should give us the right answer. Yeah, this one's a little weird, but I think it's going to be in a similar form as this. Oh, this doesn't want to know the flux across the circle. It just wants to know the flux of the vector field, right? Well, I guess that's it.
We just need to set up the integral.
What's the circulation measure again? It's can't remember how they word it. So how much fluid flows along a curve per unit time is the. Oh, that's flow. Here, I'm going to share my screen, I think, just to make sure now we're looking at the same problem.
Oops.
Oh, are you sharing? That's no problem. You can see my screen now. I think this is what we need to do. Oh, that's the circulation. Dang it. I thought I found one that was exactly like it. I was like, this is all we need to do.
Here, actually found an example on Khan Academy.
Okay, let me get out. I thought I finally found one. I was happy.
Thankfully, it is a slightly different problem. For a second, I accidentally thought that I found the exact same problem,
Mm-hmm.
but theirs is x squared and y. So the first thing we need to do is find the parameterization of the circle and then find the function for n.
So our R of t is going to be 3 cosine t
Yeah.
and 3 sine t, right?
Yeah.
Or do we need to? Or is it going to be 6 sine t?
I don't think so, because then it would be squared for the first one. So I think that the example that we saw was right then, where it's just 3 cosine t, 3 sine t.
So the R prime of that is going to be negative 3 sine t and 3 cosine t.
And then we do it between 0 and pi.
Yeah, we'd already figured that out, pretty sure. Okay, so what do we do next?
So next we need to find the unit normal vector, which is one of these four.
Okay, so the normal vector is going to be your y prime. Let me think.
Apparently in their example is x over 3 and y over 3. Oh, because the 3 is coming from the...
It's coming from the magnitude.
Oh, yeah. As a
So
3.
so for us it's going to be,
It would actually be the same, because x and y is just some point on the circle. Our circle looks a little different, but technically it's the same. X and y for us is just some point on the circle, so n equals x over 3. Ah, child.
That seems kind of, well, what about our 2y? How does that apply to that?
Oh, down here. You see?
Why is that one squared?
Because that's the magnitude. Because the magnitude of this is 3 squared sine squared t plus 3 squared cosine squared t.
So you're going to get 3.
What? What's wrong, bud?
I don't know, that just confused me for some reason.
Well, if you stop pushing airplane mode. Malachi, not right this second, okay? Buddy. Sweetheart. Let me finish this problem and then I'll cuddle you, okay? Buddy, I'm not torturing you. You can't make me feel guilty.
Nobody can make it hard for you.
Do you want me to mute it?
It doesn't bother me. I guess I'm just struggling with getting the N right. Because I would assume if we get N.
Well, N makes perfect sense to me. X and Y is just some point on the circle. And since it has a magnitude of 3, that's why it's divided by 3. So our N is the exact same.
Well, I don't know. I'm still having a hard time because it's supposed to. What I understood was N is basically equal to the vector y prime and then negative x prime. And I wrote
Where are you getting that from?
Flux density divergence in Green's theorem, it looks like, week 12.
Malachi, if you keep it up, you go to your room. Yes. And stop. Don't give me that attitude, mister. Last chance. Okay.
All right. Let me just. Oh, come on. There we go. Okay, let me see.
That's in Green's theorem, though. We're not using Green's theorem.
Oh, it's the flux version, though.
That's true.
But I was looking where it says N, mainly.
Okay, where does it say N?
And now I'm not seeing it. And this is the exact spot. Okay. Oh, it's in the divergence. Well, just showing what n is real quickly is
Okay. No, that's the correct thing.
that x prime of t, y prime of t is tangent to the curve, but y prime of t minus x prime of t is perpendicular and points outward, which is what we're doing right now, right?
Yeah.
So that's why if we dot our f, which we can put 3 cosine t, 6 sine t, and dot that with our our y prime and minus x prime, that should get us what we want, which is this form right here. And if we ignore the 1 over a, I think this might be pretty similar.
Well.
Well, anyway, I don't know if it's correct or not, but from what I see, if we just dot our f that we parameterized with our n, which is going to be this now, that should give us enough to set up, right? We don't need to worry about the other parts of this, just doing that part. I think that's what I'm wondering. That's why I was just confused about that over 3 stuff. I don't know what that means exactly.
It makes sense to me. So I don't know. I mean, as far as any of this makes sense to me.
I hear you.
Anyway, I have an answer.
Let me try my way and then see if it's the same.
That sounds good.
Because in theory, they should be.
I'm going to go eat lunch and try to get my son down for a nap.
Okay.
I will text you as soon as I'm done to see if you still are able to work on this.
Yeah. What time are we at right now?
1 o'clock.
Okay. If you get done before, give me at least till 1:30.
Oh, it will take me probably till 2.
Okay, that's fine then. That gives plenty of time. So.
Yeah.
I probably can go until 5-ish tonight, and then I need to prepare for my other class. Oh, no, that starts at 5, so maybe 4:30.
Okay. No, that's perfect for me too.
Okay, I'll go ahead and post this on and give you the code for it, or the link for it.
Okay. Then we can just submit it, and then we don't have to worry about.
Yeah, about that part, and then I'll finish 2 for sure, and then we'll see how far I get.
Yeah.
I might just take a little break, like you did, and have lunch and
No.
work a little bit.
Help me think. I know that.
Yeah. Okay, perfect.
All right, I'll talk to you in a little bit then.
Okay, sounds good. Thanks.
Bye.
Bye.